Hey everyone, welcome back to Cracking the GRE Math Subject Test. We're on the Number Theory and Abstract Algebra chapter. This is our last problem. It's the 20th in this chapter. And in this problem, we're given three sets, and we're asked which of them is a subfield of C. So remember that in order to be a subfield of anything, you have to be closed under addition and multiplication, and every non-zero element has to have an inverse. So let's check. In the first set, k is a plus b root 2/3, where a and b are rational numbers. So if we want to check if it's closed under addition, we can take two elements of this set, a plus b root 2/3 plus c plus d root 2/3, where a, b, c, and d are all rational numbers. And we get a plus c plus b plus d all times root 2/3. Well, a plus c, that's going to be a rational number because it's a sum of rational numbers. Same with b plus d. So this whole thing is going to be in our set. So we're closed under addition. Let's check multiplication. A plus b root 2/3 times c plus d root 2/3. That's going to give us ac plus b d 2/3. Okay, this whole thing is a rational number, plus bc plus ad all times root 2/3. Now this whole thing is also a rational number, so this whole expression is a rational number plus some other rational number times root 2/3, so this has to be an element of k. Finally, we have to check that each element has an inverse, so let's take 1 over a plus b root 2/3. So remember, to find the conjugate, or to find the inverse, you multiply by 1 in the form of a minus b root 2/3 all over a minus b root 2/3. We do this in order to get rid of the root in the denominator. So that's going to give us a minus b root 2/3 all over a squared minus b squared times 2/3. Well, a squared minus b squared times 2/3, that's all going to be a rational number. So a divided by that is also rational, and b divided by that is also rational, or minus b. So this is also an element of k because it's a rational plus another rational times root 2/3. All right, well, let's move on to, so we can say that the number 1 is definitely a subfield. So the answer is either A or B or D. Okay, so now we have to figure out, is 2 or 3 a subfield? Well, let's see. Number 2, it's all the numbers a plus b root 2, where a and b are rational, and the product of a and b is less than root 2. Well, if we just take a simple example like 1 plus root 2, and we add it to itself, well, 1 plus root 2, that's going to be an element of k because 1 times 1 is less than root 2. But if we add these two together, we'll get 2 plus 2 root 2, which is definitely not an element of k because 2 times 2 is 4, which is greater than root 2. So 2 does not work, so we can cross out option B. And the next one we have to check is 3. So let's move this up a little bit. So 3 is the set of all numbers a plus bi, where a and b are integers, and I is the imaginary number. Well, if A and B were rational, I think this would work, but as far as A and B being integers, I think we have a problem, because when it comes to inverses, we know that the integers are not a field. So let's say if we want to take, well, actually, even if we take just the number 2, 2 is like 2 plus 0 times I, and we know that 2 doesn't have an inverse, so in the integers, so we know that this is not an element. So like the inverse of this is definitely not an element of K, so this doesn't work. So our answer is only 1.